My name is Sarah Fleischer. This is Physics 1550, Fall 2010. Newton's first law of motion can be stated as an object remains at rest or in uniform motion in a straight line unless it is compelled to change by an extremely imposed force. This is according to Saint-Davy, the author of the European Physics Journal. In other words, the velocity of an object will not change unless another force acts on it. All objects resist change in their state of motion, which means they tend to keep on doing what they were doing. An example of Newton's first law is a car and its motion. As a car is moving forward, the driver is also moving forward. When the car is stopped by pushing the brakes, the car will stop. The driver, however, will continue to move forward unless the force acts upon it. As a car is moving forward, the driver is also moving forward. When the car is stopped by pushing the brakes, the car will stop. The driver, however, will continue to move forward unless the force acts upon it. Okay, so another way to show an example of this is a pickup truck. This is my pickup truck, and right here you can kind of see that there's like dice or maybe an air freshener hanging from the rearview mirror. And the point of that is to show when you are driving, it will look like these dice are moving backwards. So, to show more of an example, what that means is when you are driving this way, whatever is up here will be moving backwards. Now to you in the car, they may not look that way, but to someone driving by, you will see these dice moving this way. And again, with Newton's law, if you were to hit your brakes and the car would stop, these would sort of swing probably back this way a little bit and then come to rest. So it all just is another way to show that. Okay, so back to the first example, someone is driving, and again, when they are moving in this direction, your body is also moving in that same direction. However, when you stop the car because something's in the way, your body will still continue to move in that same direction. So, in order to stop this from happening, you need to wear something like a seatbelt. When that seatbelt crosses you like that, that will be the force that stops you. So again, when you're moving this way, you need the seatbelt, and that seatbelt stops you right there. You can't move forward, you can't move that way. According to an astronomy class at the University of Tennessee, which is Astronomy 161, Newton's first law of motion is very similar to Galileo's concept of inertia. And Galileo's greatest contribution to physics is his concept of inertia. The concept of inertia states that an object in a state of motion possesses an inertia that causes it to remain in a state of motion unless an external force acts on it. Basically, again, the same thing as Newton's first law. Another good example of Newton's law with a car is a car is traveling at the same speed. If a car is traveling at 60 miles per hour and you keep your foot on the gas, it will stay at 60 miles per hour and it will not change unless a force acts upon it. An example of force acting on it would be wind. If it's very windy, that car will no longer stay at the same speed. If it does stay at the same speed, it will move from a straight line. When the wind blows, it will no longer be going a straight line. It can blow the car vertically. A car that is traveling along this way will continue to travel in that straight line. As Newton's law says, it will always stay in that straight line. However, it can change direction. The way it can change direction is if this car down here if that car moves in this direction and strikes this car. If it strikes this car will no longer be moving in this direction. The car will end up moving this way. This car down here would be the extra force. This would be the force, and this force would act on this car, changing its direction according to Newton's law.